Perfect. Is everyone able to see my screen well? Just kind of give me a nod. All right, perfect. Good. It worked. Okay. So what I'm going to talk to you about today is unlocking the value of your data team. When I talk about unlocking, people say, okay, well, why is it locked up? That's where it begins. Companies feel like they're getting value out of data science. Companies feel like machine learning is returning value to them because they oftentimes don't know how to measure it. They're used to traditional software development. They're used to a completely different paradigm. So they look at data science teams like software teams, and that's one of the points that I'm going to touch on in a little bit. That's why value is locked. Because when we look at data science teams like software engineering, we expect the same types of value to be delivered. But then why do we have a data science team? If it only does software development and software engineering, if it only fits into that traditional software paradigm, why are we paying so much for all of these people? Why don't we just use our software developers? So getting into who I am, I have a bit of a compressed timeline. So instead of going through it, I'm just going to say, hi, I'm Vin Vashishta. I have been doing technology for 25 years, data science and machine learning for over a decade. The reason to listen to me is because I've done so many of these over the last 8 years. I've seen more different problems, different variations on the theme of trapped value, themes of data strategy and AI strategy not being implemented from the very beginning. I've seen enough problems that I can present multiple perspectives to you from different companies aggregated together into this one presentation. This will generalize nicely, and the frameworks that I'm going to give you are hopefully going to generalize to some of the problems and challenges that you are seeing. Value is trapped. And what does that look like? What are the symptoms of trapped value? Obviously, projects don't get to production. I think that's the big one everyone hammers on. Why aren't we getting to production? Why can't we get anything into the hands of users? But that's only one side of what I call the AI last mile problem. The model gets built. We have an expert team, the data scientists, the analysts, the data engineers, the ML engineers, this wonderful team sport. They are delivering, it gets into production and no one adopts it. And that's really the missing the mark for user needs and customer needs. That's the other side of this, is it's not enough to simply solve the technology problem. We must also solve strategy problem, culture problems, alignment with users. And that's the other side of this AI last mile problem. Companies focus on the technology. Data organizations focus on integration, pushing it to users. But if no one adopts it, if it doesn't integrate with workflows, if it's unreliable, no one keeps it. They pick this thing up, they say, okay, awesome. They use it for, and I see this so often, they'll use it for 2 to 3 weeks. It doesn't do anything that they need it to do. It doesn't fit into their workflow. It fails intermittently to do what users expect it to. And 2 weeks later, they have abandoned it completely. And if we don't have a focus on the user, if we don't have a focus on the actual business case, the utility, what we deliver misses the mark. We lose trust. People are very reluctant to ever adopt it again. And this is frontline users, senior leaders who are using decision support, who are using models and advanced analytics to make business critical decisions, customers across the board in every one of the main use cases. That loss of trust, you don't get it back. And as a data science team, this is where we truly struggle, is this side of the AI last mile problem. Now, what's the difference? How do we get from a company that's struggling to a company who is what we call a leader? Accenture calls them leaders, and they do surveys pretty much every year. And according to Accenture, leaders are making 50% better growth than laggards are. What I see in leaders versus laggards is leaders are progressing faster. The power of AI, machine learning, is it accelerates the pace of business. And leaders are able to implement strategy more confidently. They're able to figure out what's broken because no strategy is perfect. Any new initiative that goes out, whether it's a strategic initiative or a technical initiative, imperfect. And so one of the core concepts of business is identifying issues, finding the root cause instead of addressing symptoms, addressing root causes. So you are able to learn and fix faster. With prescriptive models, you are able to now understand what we should do about what's broken. You have a greater level of confidence in the improvements that the organization is making. That's the trapped value. If we do not get to the point where data science is succeeding within the organization doesn't move fast enough. And laggards at some point are going to be so far behind that there's just no way to catch up. I call this the great business die-off. And I think over the course of the next 18 months, we're going to start seeing that chasm lead to businesses going under, businesses failing. It's critical now for companies to make this transition from laggard to leader, because if we don't, there's simply no way to remain competitive. There is the challenge. Aside from what all of the large consulting companies are showing from a revenue, from a growth standpoint, from share performance and company valuations, it's the threat that is significantly larger. And that's what I want to bring home. I don't typically like selling fear. I like to sell opportunity and hope and revenue and cost savings and productivity. But if businesses don't get there, it's over. They can't remain competitive. It's just too far to catch up now. The first piece of transformation, the first piece that I see separating organizations that are leaders versus laggards, this is the first behavior. It's this concept of centralization. The majority of clients that I work with start out with data resources scattered throughout the company. There are formal data resources and people who have sort of been drafted into service as data resources. They're domain experts, frontline workers, people who have just enough understanding of data and analytics to use Excel in a very advanced way to start showing some reports. And you find all of this data is all over the enterprise. There are different systems, different applications that do the same thing for different organizations. So we have data all over the place. Some of it's managed, some of it isn't. We have resources all over the place. None of them use the same tools to accomplish their jobs. No one's thinking about products in a standardized, rigorous way. It's chaos. That's where my entry point for most engagements is. And what I see in a more mature organization, and this is something Meta did very early on, they centralized everyone. They brought everyone together, and this is your center of excellence model that you'll see more and more companies adopting. It used to be a Fortune 100, Fortune 500 only type of strategy, but I'm seeing it over the last 4 years especially, increasingly in SMEs, even startups that have absolutely no organizational structure will centralize their data resources, centralize their infrastructure and architecture. And you can see the advantages that I've listed out here. They're very significant when it comes to speed. And that's the one I want to emphasize, is higher project velocity. When resources are centralized, projects can be extended. So if I am doing an initiative for marketing, that model that I'm building out could have utility to other organizations. And the only way that ever gets out of marketing and gets into other parts of the business, especially pricing, when I build pricing models, I can pull from supplier data, cost, issues with logistics. Those are part of my pricing model, part of building that out. Information from marketing, that's another one that's critical to a pricing model. You can even incorporate strategic goals into pricing. There's so much data that you can get from across the organization for models like this, that when you have a centralized organization, the entire enterprise now is feeding data in and feeding needs in to this center of excellence. And so one problem can be extended out, and the solution can touch multiple organizations, or multiple organizations can feed into one project and produce a more holistic picture of the enterprise. If you look at struggles that companies like Nike are having with inventory right now, Nike, Target, Walmart was impacted by this as well. You look at the number of retailers that do not have visibility into their end-to-end inventory planning system. It's just amazing that where we are now with these advanced businesses, they still haven't gotten here. They have centralized to an extent, but how do you not have visibility? How are you not centralizing it in more of a uniform, rigorous way? There are the dangers when you look at not centralizing, not having a single view, because you don't see the big picture. There isn't this centralized data. There isn't this concept that this initiative that we're doing for supply chain or for inventory tracking and planning needs inputs from multiple groups. And that's the danger. Second behavior. Transformation is continuous. I love this picture. It's just simple. You heard the CEO of VMware likes to say that we are in a generational transformation. No, we're not. That's the worst view you can take. It is hobbling to think that there's a finish line for transformation. And so this is a behavior that I see in laggards, is they think it's going to be done at some point. What that does to an organization is it looks at data as if it's part of something else. Data is just digital transformation with extra steps, and it isn't. It's a different transformation. When you look at it with these waves, you begin to realize that it's no longer generational. And something that Rita Gunther McGrath, in her early book, The End of Competitive Advantage, she pointed out that transformation is now continuous. It doesn't end, and it's faster than it used to be. Think about how long it was between web, that retail disruption of e-commerce, and then our next wave, digital transformation. And then right on the heels of that, cloud. Behind that, data, analytics, AI, platforms. If you want to know what Web 3.0 is, it's just platforms with cooler marketing. And then on the other end of that, we have quantum, probably main, huge, centralized quantum computing resources, maybe 5 to 10 years out, where the early adopters are going to start actually using this. And so transformation is no longer this one-time event. And when you view it this way, and you see each one of these as distinct and individual waves, you start to realize that you need strategies for digital, right? We have cloud strategies. We have data strategies. We need an analytics strategy, an AI strategy. All of these technical strategies are disconnected if you look at transformation as a one-off, as a one-time event. Then you're just saying, oh, well, the one-time event now has cloud in it. Oh, the one-time event now has data in it. No, this is a continuation. And so whatever strategy we put in place at the very beginning needs to support everything that comes after it. If we make a decision about our digital transformation, that has to set up for data, for AI. Otherwise, and this is what I see in laggards, is there's this forklifting that has to happen in order for a company to go from, we're using applications and bots and APIs, to now we're collecting data and we're able to put it into a centralized repository. We have to create all of these ugly workarounds if we look at transformation as a one-time event, because decisions are made in silos and in isolation from each other. This is what most of us call holistic technical strategy. The majority of large investors and VCs are beginning to start talking about this concept of we invest in technical strategists, because technical strategists combine two worlds, the business world and the technology world. And when you put those two capability sets together, then you can create a technical strategy, and you can bring in experts who can build out each one of these strategies under the technology strategy umbrella. So the business now has this third leg. You have your business model, your operating model, and now you have a technology model, because anything that creates value needs a strategy, and it needs a connection back to your business model and your operating model. That's the purpose of technology. It shouldn't just serve itself. And that's what happens in so many organizations, is instead of technology serving the business, technology perpetuates itself. That's technology for technology's sake. It ends badly. The process and product side of data strategy and AI strategy is missed. And I referred to this a little bit earlier when I said that we treat it like software. It isn't. We have 4 distinct phases, and model development is the only one that truly resembles a software development process. Model development is where you're writing code that's intended to go into production. It contains the model, and it's typically launched in an API. That side of data science, you can manage it with Agile. That's where most companies stop, is they look at model development and they say, this is data science. And it fits in this nice box of software development and software engineering. And that's where I started at the very beginning and saying, if you do that, what's the point? Why not just have software engineers? You can import from, you can train, test, ship it. If that's what data science is, why do we have data scientists? There's no point to us. There's no value add until you begin to see this as an entirely bigger picture, where software engineering and software development is actually the lowest value activity we perform. That's the thing we do that we really shouldn't be doing as much. When we're more focused on the data side and not just data engineering, again, we try to shift data science into a software engineering paradigm. So we talk about pipelines, we talk about transformation of data and moving it around and cleaning it. No, it's not what we do. We curate data. We create data sets. It's one of the most valuable assets a business has, is these novel data sets. And if we are curating, we are also in the process creating ontologies. And ontologies are how business knowledge and domain expertise ends up being put into deep learning models. And we begin to move towards causal methods using this concept of curation versus data engineering. And at the very earliest stages of maturity, data can produce a ton of value. And that's where most companies are stuck, is they begin to use data scientists for these low reliability, human in the loop type products. If a person is going to be hands-on with a particular process, then it doesn't have to be very reliable. You have this check, you have an expert who's going to look at this and say, I don't agree with the model, I'm going to disregard it. And that process of introducing data into an expert's workflow, whether that's a customer or someone internal, we are now producing data from those activities. They are telling us when our models are wrong, when our data is misleading us. McDonald's does this with their customers. Those digital boards that McDonald's is far more popular in the US. So when you go through the drive-through, you have these digital boards that have the menu on it. And what the data science team figured out at McDonald's is that we can now put special offers and recommendations, just like you would see in Amazon. Customers who bought this also like. but a little bit different approach to it. Hey, do you want an apple pie? And in the United States, do you want an apple pie is extraordinarily successful. We love dessert. And what they're doing is they're introducing data into the customer's workflow. Now, what happens? Does that customer change their behavior? And that's your research phase. When you introduce data into the workflow, I now have access to the system that I'm trying to measure, and I can do experiments. I now have this ability to see, okay, so I've made this change. I've done this intervention. And that intervention is simply introducing data. What happened? Was there a change in behavior for the customers? That's what McDonald's found. Yeah, customers started buying more, and they can continuously improve the types of data that they provide to the customer with respect to an outcome. And that's where you begin to get into maintenance and MLOps. We have this intervention. We have this data that we're introducing. We have this process. It's successful. Now let's keep building and improving. How, what better data can we add in? How can we better improve our models and our predictions and our recommendations? And how can we continually optimize for a business outcome? That's data science. And in a laggard company, they never get to that phase because they are stuck thinking about this in terms of just traditional software engineering, traditional software development. And that leads very much into this next piece, which is requirements are different too. We don't have functional requirements because machine learning doesn't work. It doesn't. It doesn't work like software does. If you have an in-home voice assistant, you can ask Alexa. I have Alexa at home here. Amazon's product is pretty awesome. I can ask it, what's the weather going to be today? And every single time it will tell me what the weather is. So it works. And companies fall into this thought process that, okay, it's just like software. But it isn't. There's no way that you could write up a requirements document that would include every question that an Alexa or any other home assistant could be asked. I could ask it, where's the nearest place that I can find jelly beans? It may function very well, or it may have no idea what I'm talking about. And this is the sort of user experience differentiation, is there are a set of use cases where it must perform with very high levels of reliability. But models do this other thing where I can try stuff out and it might work, it might not. If we don't advertise to our users these reliability levels, they don't know the difference. If they treat it like software, they don't understand where it may begin to perform and behave unpredictably. And so this concept of reliability, and this is data literacy getting into model literacy. Leaders have a comprehension that it is not all the same. Not all data is created equal. Not all models are reliable in the same way. And so as data scientists, we must publish when our models they'll perform very reliably, not perfectly, but very reliably. But there are other instances and use cases where they won't. We have really no clue how they will perform in these situations, or we know they will perform unreliably in certain circumstances. And again, I'm going to go back to supply chain and inventory planning. The models behind customer demand did not see changing patterns. Customers are moving from products to experiences. At companies like Walmart, customers are moving from brand names, these branded items, to generics. And that's one of their behavioral changes to save money. The models were not watching for any sort of these changes. And so that's a MLOps and your maintenance and continuous improvement problem. But users didn't know that if something like this were to change, if there were to be changes in customer preferences, that they needed to stop relying on these models as accurate and highly accurate so that we could make those decisions. They didn't know that. And so they'd given up too much agency to the models in most companies because they were bright during normal times where they had been trained on data that made sense in those times, that fit with those times where customer behaviors were consistent. Models worked, and we get complacent in companies that don't understand the difference between their reliability requirements, we get complacent. We say, oh, this works now, therefore it will always work. It will never fail me. When we understand reliability and when data science partners with the business, we begin to explain if these basic assumptions change, stop relying on this model and call me immediately. I need to fix something. I need to change something. We truly should be monitoring for these changes in upstream data. And if we're doing that, if we're advertising how reliable our model is, users are still in the loop and they still have agency over decision-making, and that's from customers to internal users. Then when models start behaving unpredictably, we know, hey, it's time for us to get involved. We have to do something about this. We can't just hand over agency. And when that doesn't happen, when we don't understand that in high reliability use cases, or when we turn over a large amounts of autonomy to models, they require this higher level of evidentiary support. When we as users don't know that, you have problems like what we're seeing with inventory, supply chain difficulties, demand planning. Airbnb, very good at doing this because they almost died at the beginning of the pandemic. There was this, their CEO says, we had this existential threat where we stared into the abyss, and they decided to become data-driven. It was the event that drove them to rely more heavily on data and analytics. Customer behaviors are changing and Airbnb knows it. Customers are now preferring larger properties. Their customer sort of makeup is changing to families who want these larger properties in premier destinations for longer periods of time. And so while the rest of the world is looking at them and saying, oh, Airbnb is in a lot of trouble, they understand, no, customers are finally figuring out our value proposition, our unique advantages, in that trying to book the same thing in a hotel just is not possible. And so we can offer these large homes, we can offer these experience destinations, we can cater to this new type of spending pattern. And so as one side of the business begins to lag, they are focusing on a side of the business which is moving forward. They are watching for changes in behavior, and as a result, they're thriving. These three are fairly self-explanatory, but I want to at least take a couple of seconds to go through each one of them. Continuous model improvement, talked about that in the MLOps framework and in the last example. But the laggards really are fire and forget. They will put models into production and no one looks at them for years. This is catastrophic from two perspectives. First, they stop working after 2 to 3 months. Second, users abandon them and no one knows. I've been into companies where I've pulled usage statistics from models that were allegedly making the company a ton of money and no one had used them in months. That's a horrible realization for the data science team, that they were disengaged and siloed so much from their users. They had no idea what they delivered. No one was using it. Why aren't you getting complaints? Well, that's why. No one cares enough to complain to you, and that's a huge problem. Champions, in laggards, you see this scattering of people who have had some level of success at the front lines or at the director or manager level, and they advocate for data science and machine learning, but no one at the top has ever touched machine learning. They've never seen it. They don't understand it. So no one's championing it. No one is willing to, especially now, risk potentially their career. You know, if you're at the C-level right now, making a mistake, not the time to do that. Not the time to put $1 to $2 million into an initiative that doesn't do anything for you. And so there's no champion because they don't understand the value proposition. And if you don't get one person at least on the C-suite bought in from the beginning, their data science just doesn't get to achieve its potential. And then finally, this one, you would think it was obvious, but it isn't. Vanity metrics rule laggards. One of the powers of data science and machine learning is we can move from vanity metrics to causal KPIs. That's something that Amazon is working towards. They use more sophisticated KPIs. They are looking for causes rather than symptoms. This is something I alluded to at the very beginning. When you understand causes, your decision-making process is more effective. When you understand causes, you can measure the right things rather than introducing metrics that I think they sound good. Marketing is an example where you see so many vanity metrics. We want engagement, we want click-through, we want, well, right, but what causes a sale? Does click-through cause a sale? No. Okay, so who cares? Let's get to the KPIs that actually cause a particular segment to decide to buy something from us. Let's find out what causes someone to become aware of our product, but awareness in a way that leads to revenue, that increases lifetime value, that increases loyalty. Any one of these that we know leads to more revenue, let's figure out what causes it. And so instead of going through vanity metrics, leaders will dive in and just say, why? No, I'm not satisfied with what or how. I want to know why. And so how do you get there? What is the maturity model that, this is the one that I follow. I get brought in typically at an early level of maturity. Again, I talked about this where things are inconsistent, resources are all over the place. There's no centralization. No one really understands how to measure the success or failure. And so the initial assessment, if you're in one of these early maturity companies, this initial assessment is critical. Figure out where the business is. Because if you don't have a starting point, and if it's not an honest starting point, and it's not just from an external standpoint, you have to look at the data team and say, okay, what can we actually deliver? Can we do any of the stuff that the business expects us to? And that leads to the major piece. Well, okay, what does the business expect us to deliver? And so we have to dive back to core strategy. We have to connect it all the way back to the opportunities the business has already identified for growth, for cost savings, for improved productivity. And instead of the data science team saying, here are the things we could do, the business should say, these are the things we should be doing. And now the data team comes in with, under that technology model and technology strategy umbrella, and says, okay, and here's how we can make you successful in doing those things. So now it is core strategy saying, this is what we're doing. And data science teams are coming in and saying, okay, great, here's what we can do to help you. And now it's part of strategy planning. Your data strategy and your AI strategy explain why the business uses data to achieve strategic goals. Why are we going to use AI to achieve these strategic goals? And that makes you justify it. This concept of strategy is an evaluation of trade-offs. Should we use data science? And the answer to that, 95% of the time, nope, no, absolutely not. We should use either traditional software development methods or basic descriptive models. Data analysts are so underutilized. They can produce so much value. It is in those 5% of use cases where there isn't another option, where data science provides more value than any other approach. That's what we need to focus on. And this maturity model is how you get there. You go from that initial assessment, where are we? Technology model, your transformation strategy, your innovation strategy, which is picking those initiatives that data science should be working on. Then you need roadmaps. Organizational build out. The data and analytics organization needs to be centralized, but it also needs new capabilities. Now let's talk about products, and not just internal products. What can we give to customers? Can we create data products? And this is a very quick path to profitability for startups, is realizing that they have all this data, and in less than a quarter, you can convert that data into something people will pay for. And then finally, now we're going to AI. We're setting up for, in this continuous transformation process and this maturity process, we're setting up for it with everything that came before. Now we're ready to do AI. Now we're ready to actually put more reliable models into production. And when you start a maturity journey, there's pitfalls. And again, this is that laggard versus leader mentality. It's not about the technology, it's about the value. It's about customers. It's about users. It's about bringing them into the process early and often. They need to be part of the planning, opportunity identification, incrementally watching demos and assessing whether or not this truly fits the need. And then that validation piece and acceptance. Is this what we asked for? If they're not part of that process, data science is set up to fail. Don't talk about tactics. When you say strategy, I see this so much. What's our AI strategy? Well, we're going to hire some people. We're going to bring in some infrastructure. That's not a strategy. Those are tactics. Why? Strategy should be asking why. It's an evaluation of trade-offs. Initiatives and strategies should not be siloed into the data team. It's business-wide, enterprise-wide. The enterprise needs to be part of it from start to finish, soup to nuts. And don't start with data science and machine learning. Just don't do it. I've talked about the 5 steps that launch a data strategy, but I want to hit on one, and it's that coalition. Building a coalition around use cases. We can lead strategically as a data organization, as data organizational leaders. We can build these coalitions that begin to advocate for data science and advocate for machine learning. Because when it's just us saying data science is amazing, C-level people are saying, well, of course you're going to say that. We need users across the organization, not just that C-level champion. We need coalitions of people, product management, project managers, frontline workers who are going to benefit from the solutions, whose needs are going to be met in these use cases, and product managers especially, because we need to generate revenue. We need to make some money for the business. Data science teams don't do that enough. We need to get to revenue generation as fast as possible, because when I say continuous transformation, every wave must be self-sustaining, meaning it must become cash positive. It must become a revenue generator. Each wave cannot be a cost center because we have this long-term thing. It doesn't work that way. They must all be self-sufficient and self-sustaining. And so it's important that revenue gets booked against what we do at every phase, data analytics and AI. I know I ran a little bit over and I apologize for that, but thank you. I appreciate your time. I appreciate your attention. I know some of this can be fairly dry, so I greatly appreciate everyone staying awake through the entire presentation. I'm going to definitely take questions, but I also want to hear comments. What are your thoughts? What are you seeing? What challenges are you running into? And I am going to stop sharing my screen and let you get in here.
Thank you, Vin. So beautiful and so insightful. I couldn't agree with you more. And it's very nice, really, that you so nicely abstracted everything, and it's very nice, consolidated, crispy version offered the package. Here is something you need all your focus on here. And it's indeed a very precious gift to our community.
Thank you for having me.
Other questions? Something you want to know more? It's an opportunity that Vin is with us, and you mentioned about the coalition that I, of course, understand what you mean. And we also approach it in my company. Who is, in your opinion, number one that we should think about data science hand in hand with another discipline forming coalition?
That's an interesting question. I think it fits with every discipline. And I think that's the power of data science, is that no matter what field you come out of, from a research standpoint, data science fits. No matter what domain that you work in from an industry standpoint, data science works. No matter what particular business focus or business function that you perform, data science works. And we need people not just from data science going to these organizations. We need people from these organizations becoming data scientists. We need people from different research disciplines becoming data scientists. Because in 2014, 2015, I learned how to do data science from hard scientists. I learned from physicists who explained, okay, so what you've been doing is descriptive modeling. That's not good enough. And they explained the concepts of bringing in observational studies and said, congratulations, your models are an observational study that you're doing unintentionally. And so you can hear that. And they taught me more scientific and rigorous methodologies. And so every discipline is going to be able to help data scientists be better at our jobs. And we can, in many cases, you're seeing it in pharmaceutical research, you're seeing it in biology. We help design fusion reactors. Data science, if you understand its limitations and you do it in a rigorous manner, we can help a lot of different disciplines. And there is no one, but I think we won't be successful until we have that cross-pollination.
Mm-hmm.
I have one question. So I worked as a data analyst before in a product team, and also like for the setting up the whole infrastructure and tools for the company. And what I found the most challenging is actually to get the company, the stakeholders into this data-driven mindset. And for us, it was always basically the biggest challenge to help them adopt this data-driven mindset. So I'm wondering if you have any like advice to change a company culture into being more data-driven.
For me, it's always showing, and this goes back to that coalition and building coalitions. If I can solve somebody's problem, their biggest, ugliest, I hate doing this task, or we make mistakes in this decision more than any other, and it hurts us. If we can solve customers and users' painful problems, then they begin to look at data differently. They won't overnight become data-driven. It just doesn't happen that way. But their relationship with data changes. It goes from this is a painful thing to add to our workflow, because that's really where the hesitance comes from, is we have to stop doing something. We have to quit doing something in order to adopt data. And we are very, very hesitant to stop doing things that have made us successful. But we are more willing to do that same quitting when it's something that we already know doesn't work. We know this doesn't work. We've admitted it. It's painful to continue to do it the way that we have been. We're looking for a solution, and you can get people to quit those behaviors. And those are your gateways. When you don't have to deal with that psychological barrier, you can begin to find use cases where you're just asking the question, what doesn't work now? Where are you most challenged in business operations, in value stream and workflows? Where are customers most challenged? Where are customers using our product and we see them hate a particular piece of it, or continue to ask for a functionality that we can't give them, but not having it is causing them pain? Those are all things where we don't have to change behaviors. Those behaviors are already ready to change. And when we get rid of that psychological barrier, adoption happens and people see the utility. And those are the two critical pieces to beginning data-driven, because the relationship changes. They see, oh, okay, so this does do something good for me. And now everything else after that, when we begin to say, hey, can you change your behaviors? They are more likely to say yes. They are more likely to begin to integrate data into their workflows, because they no longer see it as only painful. They still see the pain of change, but they also see a benefit.
Cool, thank you. And perhaps to follow up, for me, the next step would be, and we also worked on that, is this kind of self-serve analytics, where you actually teach them to use the data by themselves. So because I think as a data team, you can never serve the whole company because you just don't have the time. And most of the question tasks are very easy to do, so you can teach them. And yeah, would be curious to also hear your thoughts about this transformation, then to actually teach them how to use all the tools, the data by themselves.
I like the code review concept in software engineering. Before you can check something in, somebody has to do that code review step before it ends up getting promoted to a higher level branch or potentially being promoted to production. At the very beginning of this concept of self-serve, I think it's great for, we do the training, but then what? Having anyone who's using a self-service solution do almost a request for review, where they say, hey, I've developed this, can you check it? And you can have one analyst dedicated to each business unit that just does their, call it code reviews. And what's great, I talked about cross-pollination. Now that analyst understands their business needs and what challenges they're having. What kind of self-service solutions are they building? Where are they unable to build their own solutions? And that suggests and recommends initiatives. And so now you have that cross-pollination. You're getting some domain knowledge into the data science team. And at the same time, you're promoting data literacy and model literacy. The people that are building self-service solutions are getting your insights into, hey, you're in a danger area here, or yeah, you've used something well, but let me teach you a better way. Let me give you different approaches, better tools. And that cross-pollination, you end up getting better self-service tools. And you know when to tell users, you're actually in a data science use case. Why don't we create an initiative for this? Because now we're talking about something that they understand the value, they have a need, they're bringing it to the data science team as part of this review process. And the team can say, this we could really help you with. So definitely use this self-service tool. Here are the limitations of it. And let's get this on the, and that's the coalition. Let's get this initiative booked. And now it's not just me saying, look, I've got value, I can do things. You also now have a user, or you have an organization who's going to come behind you and say, yes, we actually really need this thing. If we don't have it, here's what happens. Or if we have it, here's what we can do.
Cool. Thank you very much.
Thank you.
That was such an awesome topic. I tell from one of the examples at the Digital Project School that we organized a Meetup with Data Robot, which basically it's a no-code machine learning, no-code AI platform. And we brought our team of AI with product managers and designers. And then they started. The situation with our engineering was that, where is my command line? I hate this tool. But product managers and designers, actually, they start seeing the utility. We provided them a database, and they started seeing that they can really generate the results. And that was a time they were so open to learn more about it. The first step, literacy, was achieved, and then it formed a nice bonding with our engineering team to now get more involved and get it on the proper way, with the proper machine learning in production that is for a long-term sustainable.
Yeah, that's the blueprint. That works very well. Just when they touch it, feel it, and the data team stays engaged. Yeah, that's the setup. All right, looks like no more questions. Last chance. We got 5 minutes. All right.
May I still have
Yeah, definitely.
there's one, but I deprioritize myself. You mentioned regarding the transformation metrics, and which of them for sure are the best one in particular to infer the causality, or generally any transformation metrics that are your favorite?
Ooh, favorite metrics. Wow, I've got a lot of them. Hard to pick one. I like percentage of data type of metrics, and I want to tie those. And this is where it gets really easy to get to vanity. is you can say, you know, percentage of company or the company that's doing data stuff. And that doesn't connect to value. Who cares? So what I'll end up doing is, you know, this is the maturity model that I promote is, okay, so what percentage of business units are generating data? Because you'll find in very early maturity companies, there are entire functional areas that don't produce any data. That's crazy and scary all at the same time. There are parts of the business that are opaque. And that's what I'm using this metric to showcase, is there are parts of the business that no one understands. And if we don't understand it, how do we manage it? How do we improve it? How do we use data to improve it? So you can begin with something that simple as with business units and then getting more granular. Well, what workflows or processes, depending upon how you understand your operating model, what processes or what percentage of workflows generate data. And we begin to understand that higher value workflows probably should be 100%. Lower value workflows, maybe we prioritize that for later. Now we're using this metric for prioritization. We understand how valuable this is because we're connecting it back to the value stream. We understand how valuable this particular workflow is. That's a high value workflow. It isn't generating data. We probably want it to. Why? Because once it generates data, we can introduce. So we go from percentage generating data to percentage leveraging data. And we can then begin to say, what's the delta? Baseline, here's what business outcomes we were producing in this workflow before data. Now we are leveraging data. What's the outcome? What are the improvements or changes in value? And so it's that really simple transition for a metric like that. Percentage generating data to percentage leveraging data or using data. And then what's the delta? And that's that clear line to value.
Awesome. How clear you explain. It's amazing. Thank you so much.
All right. Well, thanks everybody for your time. I know we're butting up against 9 o'clock my time, but much later your times. Thank you. I really appreciate your attention and your time.
Really appreciate everybody and really appreciate you for your time.
All right.
Sure. See you later.
Take care, everyone.
Everybody. Take care. All the best.
Thank you very much.
Thank you.